Welcome to Programming Rainbow. In this video, we will be starting a new series for creating John Conway's Game of Life. We will be using the Lua language and the Love2D game library. So if you want to follow along with this, you'll want to go to github.com and Programming Rainbow, and then Conway's Game of Life, Love2D. So if we just take this URL right here, and we go to a terminal, assuming you already have Git installed, so you can, if you're on Arch Linux, you can run a command like this. Say love and git so we can use the git command to clone the repository, and love because that is the name of the package for Love2D. You do not need Lua separately. The love package actually has Lua built into it. And I already have both of these. So now in the top level directory, so I'm just going to cd, I'm going to run the git clone on the GitHub Programming Rainbow Conway's Game of Life. I'm just going to paste in that URL right from the website there. And it looks like it already exists, so I'll remove it real quick. And we can pull that down. So once we've pulled it down, we can cd inside of it. And we can run NeoVim, or if you're using a different text editor, maybe VS Code or any type of text editor you want to use, you could just use whatever you want to use. I just want to show you what this game is going to look like when it's done. I'm going to change something just to make it a little bit more interesting. Well, let's just run it straight up. So to run this, since I'm in the directory that it's in, where the conf.lua, the game.lua, and the main.lua files are, I'm inside this directory. When I opened up a terminal here, or if we were to open a different terminal and I cd'd inside of it, to run the game from in here, I just need to write love dot that says run love in this directory. And to show what's in this directory, we have the files that we need here, and we'll talk about these other ones in a minute. So love dot, and this is it running. So it's just, I've just put a random, it randomizes the screen. I can speed it up, or I can slow it down. I can pause it and unpause it. I can edit it. So if I wanted to change one of these, this is a stable, still life is what this is called, I believe. This one's stable. If I were to add one dot to it, it would become unstable. And now it's doing something else. See down here, this one right here is stable. If I click on it, I'm just adding one there. It's going to do something else. This 2x2 is also stable. So if I were to remove one, oh, it actually added it. So maybe if I just add another one here, it's going to do something. Okay, let me clear this out. I kind of want to show it a little bit cooler so you kind of get an idea of this. So what I'm going to do, I'm going to close this window. I'm just going to edit it real quick, just showing it off. Right now I'm running 800 by 600, but I want to change it to something bigger. So say 1400 by 900, and it's automatically going to scale. It's automatically going to figure out what size you're using and create the array for that size. So I'm going to save that file, and then I will run it again. Now I'm just going to pause it. I can also clear it with the C button, so I'm going to clear it. I'm just going to draw one of the interesting ones that does something. This is almost going to be the same shape all the way around, except I'm going to leave the very bottom open. So I'm using my mouse pointer and it's a little bit difficult. Okay, so I'm going to slow it down a little bit and unpause it. So I'm going to put it up to maybe normal speed, and you'll see this shape now is going to keep going and do all this, make more and more stuff on the screen. I'm going to speed it up a little bit. And it just keeps going. This is quite interesting shape. These are called gliders. This one here that was moving out. These two here that are moving out are called gliders. I'm going to keep speeding it up. It'll eventually stop, but it's going to go on for a little bit. But there's quite interesting. You can actually make this game of life inside of Conway's game of life. If you have a big enough array, you can actually make its own game inside of itself. It only has 4 rules, or depending on how you look at it, 3 or 4 rules. And with that, you can Turing complete language. You could do all kinds of just whatever your imagination can think of. Let's just go look, what is this game of life thing? So I'm going to close this window. This is the GitHub page that we're already, and it just has some basic information saying what it is. It's created by John Conway in 1970. It's a 0-player game. If a dead cell has exactly 3 living neighbors, it becomes alive in the next generation. That means if there was nothing there, but 3 of its touching neighbors, for each center cell, it's going to have 8 around it that touch it. So if the center cell was nothing and it had 3 of the cells around it that were actually something in it, it would come to life. If a living cell has 2 or 3 living neighbors, it remains alive. Now, if it has less than 2 or more than 3, it dies. So that's kind of, it can be 4 rules or 3 rules depending on how you look at it. In all other cases, a cell dies or remains dead, as in it won't be there. And there's just some little bit how to install it, how to run it. And here are the controls down here. The up and the down arrows speed up or slow down the iterations. The spacebar pauses it, escape quits the game, R resets it as in randomizes the board, C clears the board, and mouse clicking on it wherever you want with just the left mouse button will either add something to the cell or remove it if it's already there. Okay, so if we go to Google and we just type in Conway's Game of Life, Google automatically populates this kind of game of life game with its Google search. So this is kind of a thing that's been around for a long time. And if we go to the wiki page for it, you'll see these kind of emitters that create gliders. And here's another interesting one. I'm gonna start it backwards, and then I'm gonna make it a little bit smaller so you can see more what's happening. But with this one shape, it just kind of takes off and it starts doing a lot of other things. Okay, so there's different kind of shapes going on. These are still lifes, like the 4x4 block, the beehive, different ones like that. These are simple oscillators. These are different types of gliders and ships. It gets more and more complicated. You can make really amazing, and there is no real scale to this. You can just whatever your imagination can handle, basically. Here, this one's doing some kind of 3-dimensional knot. There's videos and everything. Yeah, here's a larger scale. This is actually, are they doing logic gates with this? I can't remember. Turing machine in Goalie. Yeah, so they're probably trying to make a Turing machine with this. So I've seen it done all the way up to the scale where they're actually creating a Conway's Game of Life game by using Conway's Game of Life to make the game inside of the game. So it really just scales infinitely. Okay, but it's a very simple game to make. We are using Love. I'm not going to cover this stuff because this is the 3rd series that I've already done on Love2D. So what I'm going to do is assume that you've already watched the other 2, and I'm going to try to move faster. So anything that I've already covered in the last 2 series, I'm not going to spend a lot of time on showing you the page. This is probably the only page that we're going to look at for this series. And just one real quick, going back over the code, what I've done here is these 3 files. These are the final code. When you download it, so you can just run it. And these 3 are actually what's in video 3. So the code that's in video 3, let me close this. These 3 files that are in the video 3 folder, they're the exact same that's in the top level. So they're just in the top level so you can just launch it and see it working. We're going to delete the top level 3 and just recreating it all right now. Also, the reason why we're having this funny icons with this red X is because the Git is still here, so I'm just going to remove that. That's fine, that error. And I'm just going to remove the top level Lua files. And if you join in from any other video, just use the files that are in the video beforehand so that you're wherever you need to be at, okay? So I'm going to remove all Lua files. That's what I'm doing here. There we go. The first thing we want to do is kind of create this file. We're still looking at it, but it doesn't actually exist anymore. So I'm going to close these out and recreate them on the left. But the first thing we want to do is this conf file. We've already covered this before. I am going to have an icon that we can load, although I can't show it to you in Xmonad. So I'm going to close these windows up here. Okay. And a lot of times I create it here on the left. I'm just going to touch them down here because that's also another way to create files. So I'm just going to use touch. We'll say main.lua and conf.lua, and we're going to use game. And I'll close that. So in conf, so we're going to say function, and it's love.conf, and there's a t being passed in here. Okay, so what we want to do is we want to set the width, the height, the title, and the icon. So it's always going to be t.window.width equals, and we'll just do 800 by 600, but as you saw that I could easily change the size of the screen and the game will scale with it. And that's because of the way that we're going to create the game. So we're going to say height is 600, t.window.title equals, and this one's going to be a string, and we'll say Conway's Game of Life. And I'll put the apostrophe s there. It's a string, so it should be fine. We'll find out. And the very last one is an icon that will load if you're using a Windows manager that does display an icon. So that icon is coming from over here. I have just two files that we actually need. One is the Free Sans Bold, the true type font. And the other one is just an icon. It just basically shows like a matrix. Let's see if I have it here. And it's right here if you can kind of see it. It's not very big icon. So that's the icon that you can use whatever icon you want. That's just one I've created. And the way that we load that is the same, where it's going to be a string, but it's going to be relative path. So we do t.window.icon equals, and it's going to be images /icon.png. Okay, so that is that file. We don't need this file anymore. I kind of want to skip over main for a second. Main, we're just going to be handing stuff off to game. That's all really we're going to be doing. So let's go into game and start working in game. The very first thing I want to do is create a table, and we'll call it game, and then we'll return it. Just going to make an empty table and return that table. The reason why I was able to automatically scale the game just by changing its width and height is because I actually calculate how many cells I'm going to have based on how wide, what size of the cell is, and how wide and how tall the screen is. I'm going to use two things. I'm going to use cell and size. The reason for this is well, imagine my cell is basically grid paper or something. It's 10 by 10. So every 10 pixels by 10 pixels is a square, and the next one next to it is another 10. But it doesn't, kind of the way, let's look at the way it was on the Google one. If you look at here, there's no border between the cells. Okay, so what I've done is I've shrunken the size of the drawable cell down a little bit so that there is a border. And this is up to you. You can change this too, but I don't like it like this, where this is 4 cells right here, but I do not see any separation between those cells. So I like it with the separation being drawn. So what I'm going to do is I'm going to create a couple constants that can be changed as if you want to make the game cells bigger or smaller, you can decide what size works best for you. So I'm going to call the actual size of the cell, I'm going to call it a cell. And I'm just having that equal 9 right now. Again, you can go ahead and change these and they will scale because of the way we're going to write the code. Changing the window size, changing your cell size will all calculate out correctly and it'll still work. So what I'm going to do with the actual size that's being drawn is going to be slightly smaller than the cell. I'm going to reduce it by 1 pixel. Now you're thinking the cell is actually going to need a border all the way around it. Well, if I would just reduce it by 1 pixel, that would actually give me a border on the right side of the cell and a border on the bottom. But remember, this is going to be cascaded. So just because I have 1 pixel, the next cell next to it, that will still be the 1 pixel between them. So I don't need to draw a pixel all the way around the cell. I only need to draw the pixel on 2 sides of the cell, or not draw that pixel rather. So yeah, what I'm going to do is say local size. Now this is going to be the drawable size. I couldn't really think of a nice name to do this, so I'm going to say cell -1. So if you ever want there to not be a border, you could just say equals cell, and it'll just be the same and there'll be no border. If you want a bigger border, you could say -2 or something like that. And the code will still work. Everything else will still work. And if you want this to be bigger, you could say this is 20. You could say it's 30. You can make huge cells. It doesn't matter. It'll still calculate out and work. So we'll play around with that later as we see it. But the way I'm going to calculate this now is I'm going to get the width and the height of the game window here. So we've set it actually in conf.lua, but I'm going to calculate it here so that I have a local version of it. And I'm not going to hardwire it in. I'm not going to use a magic number. I'm going to calculate it. So we've already seen this before where we can use a love.graphics.getWidth. So, and these are all what I'm calling constants. That's why they all have capital letters throughout their whole name. Love.graphics.getWidth. And that's going to get the width for us. That's just the width of the whole screen. And local height. Get height, that will take care of that for us. So those are all constants. Now what I'm going to do is I want to know how many rows I can have. Remember, I want to be able to calculate because based on how wide and how tall the game window is and based on what size my cell is, how many cells could I have? So I'm going to use rows and columns, and I'm going to explain it in a second here why I'm using rows and columns. But I'm going to try to make these private members, so I'm going to use the underscore again. This is just convention. There is no private members in Lua. And I'm going to say math.floor. And what this is this says, hey, round it down. Whatever the number is, round down. If I make a screen width of, say, 35, my screen width is 35 pixels, and I make my cell size 10 pixels. Well, that means I can have 3.5 cells. But I don't want 3.5 cells. I want 3 cells. So I don't need to draw half of another cell. I will just not draw that cell at all. So that's what this is doing. This is rounding the number down. And I'm going to say height divided by cell. So this is going to give us the calculation, how many cells can go can go up and down by taking the height of the whole screen and dividing it by the size of the cell, and that will give us how many rows we are allowed to have in this game. I'm going to do the same with columns, and again, I'll explain in a minute why I'm using rows and columns. And this one will be width. And it's still the cell, because the cells are a square, so. and I need a comma on these. So these are being put inside the game directly. You could also add them to the game. You know, I could have put them down here and put game.rows, but it's fine. This is just fine for me. I also need a board. I need basically a two-dimensional array, which is going to be another table. And I'm just going to declare it here and fill it in later. So it's just another table right now. Okay, so that's just what's being put in the table directly right now, the game table. Okay, so we need to fill in this board because basically this board needs to be populated. It's a two-dimensional board, so I need to make, it's a table, and inside that table I need to make as many tables as I have rows. And then each side of those rows, I need to make, you know, a member of that table, as many as there are columns. So I'm going to make a nested for loop and do it that way. But I'm going to call it the game load because this needs to happen on load. This table needs to be created for me. And again, it's dynamic. So that table will be created of the correct size based on cell size, based on width and height, based on rows and columns. That's what's going to decide my table size. We're not going to worry about that yet. So I'm just going to give a comment to this one. I'll say create 2D just so I know what's happening. There'll eventually be two boards, but not for this video. So I'm going to do a for loop. Now I can't, in all of this game, I'm always going to use my for loop being dynamically on whatever size the table is. I'm not going to use any other numbers. I'm going to say the for loop is based on what the table is. But since the table doesn't really exist yet, I can't do that this time. But later on, everything else later will always be dynamically done through the table. But since I'm populating the table right now, I can't do that this time. So this time I'm going to do the other style, the for row equals 1. And this gets a little bit annoying because Lua is 1 based. So you have to bear with me. There is a little bit of hand holding going on with the 1 based Lua because it's easier if it was 0 based, but because it's 1 based, we have to take that into account. So I'm going to use the rows. So I already know how many rows I should have because it's been calculated up here. So this is just going to be an iterator. This is going to be going from 1 all the way up to the number of rows I have. Sorry. Now for each row I need to do something, and what I want to do is I want to create a new table for that row inside the board. Because right now the board is empty. And since it's a two-dimensional board, the first thing that we need to do is populate what will be the rows with yeah, I'm just gonna draw it out down here so it makes more sense. So if we have a table, right, this, right? But it's a two-dimensional table. If we had a one-dimensional table, it would be 0, 1, 0. These are not correct. It would be like this, you know, something like that. Some zeros and ones are populating the table. That's a one-dimensional table. But our board needs to be a two-dimensional table. So we can't really do this. What we really need to do is something like this. So this is a bunch of tables, but if we put them into one table, like this, oops. So if we call it board, say local board equals, this is all going to complain down here for a minute. I'm just going to comment it out. Come on. Commas. Okay, there we go. So this is what we need if it's a two-dimensional board. Basically, it's a table, and inside that table is a bunch of tables. And inside each of those tables are items or values or however you want to look at it. So the problem comes with is when we access this board, normally when you think of dealing with X and Y coordinates, I would say, well, the X is going this way and the Y is going this way, right? So if I got X here, I got Y here. So if I wanted this 0 right here, well, this is, in Lua, we're 1 base, so let's say this is 1, 2, 3, 4, 5. 5 on the X and 1 on the Y. So it should be 5, 1, right? That's X and Y. That's X and Y coordinates. But the way we access a table is not like that. The way we would access a table or an array, you don't want to think about it in X and Y. You want to think about it in rows and columns, because board, if I actually wanted to get this 0 right here, I would need a row. Now this is a row, this is a row, this is a row, this is a row. The rows are the Y's. But the row is the first thing, because inside of this table, the first thing I get to is another table, these tables, which are rows. So it would be 1 here, and then inside of this, now we're inside of this row, for the second part of the array, it's 1, 2, 3, 4, 5, so it's 5. So that's backwards. This is X and Y, this is rows and columns. So when we're accessing a 2D array or a table or however you want to do it, you want to start thinking in rows and columns, because if you think in X and Y's, you're going to swap the X and Y backwards and it's going to become very confusing. So for that reason, I'm using rows and columns anytime I'm dealing with this kind of stuff, because if I try to use X and Y's, I will confuse myself because they need to be the other way around. So I hope that makes sense. Basically, and even if it was 3-dimensional, if this was each of them arrays with things inside of it, it would be the outermost thing first and then the innermost thing. So this first thing is going to be our rows. And then what's inside of it is going to be our columns. So our rows are kind of our Y and our columns are our X, but it's rows first, then columns. Okay, I hope that made some sense. Just going to delete that and we'll uncomment this. So that's the reason why I'm doing rows. I'm counting rows first, and for each row, I need it to be a table. So I'm going into the board that we've declared up here, this board right here, and I'm adding a new table for each row. So I say row, which this is just an iterator right now. I'll say equal empty table. Now we need to fill up that row with our columns, which I'm just going to put zeros in. It's always going to be zeros or ones. So I'm going to say for column equals 1, again, because it's Lua. Self columns. So this is going from 1 to however many columns we have. 2. And what I want to do in here is I want to set the column that we are creating to a number. So the row is still there. Now it's the column. And I'm setting that to 0. So this is kind of help populate this board. So the first thing I'm doing is making another table for each row, and then I'm iterating through how many columns it should have and putting a 0 in there. So it's populating the entire board with a bunch of zeros, well, a bunch of tables and zeros. Tables for the rows and zeros for the columns. So that's going to give us our 2D array. I also want to reset this, and when I say reset it, basically I want to randomize this. So now we're going to see the other way that I'm always going to deal with this board, the way that I'm going to have the board tell me what size it is, the table, the board table. I'm going to have it. And here I'm telling it what size the table needs to be. Now that that's done just one time, for the rest of the time, I'm always going to have it tell me what size it is for the for loop. So I'm going to create a reset method, and it's actually going to be called from load as well. But we're going to create it first and see what it is. And this is just going to randomize because we're putting zeros in there. We can just randomize it. And the reason why it's going to be separately is because I can use it more than one time. Whereas the creating the board only needs to happen one time. So this for loop is going to look a little different because I'm going to use I pairs on the actual board. And that's going to give me an iterator that I'm going to call row. So this I pairs, I'm going to pass in the table. So the self._board. That's the table I'm passing in. And this is going to give me a back I pairs, an iterator and the value that's there. So we're going through the rows. So for each row, it's going to be full of columns. So that's why the row is going to be the iterator. And this is going to be the column. This is going to be one of the rows, one of the tables that is the rows. But what's inside of that table for that row is the columns. So it's a little bit confusing. In my notes, I have it row in rows, but it's not really correct. For rows, it should be columns. Now I'm going to go for a specific column as the iterator for column. And I don't care the value that's in the column right now, so I'm going to use an underscore in I pairs, and it's going to be the columns. And there should be a do up here. So what I've done here is I've got out the iterator of the column, and this is the column table. The column table contains, the row table contains all the columns. So here again is the row table with all the columns in it, and I'm getting each one of the columns out at a time. But I don't care about the value. I just want the iterator, that here and here. And so what I'm going to do with that is I'm going to set that item, just like we did up here where I set it to 0. I'm just going to set it to a random number. So this one's going to be row and column. And that is coming from here, the first iterator and the next iterator. That's the row, that's the column. And I'm going to put it equal to, and I'm going to use the math.random. And I want it to be either 0 or 1. That's the only thing I want to happen in this thing. So it's always going to be a 0 or 1. That's what I want it to be. And I'm just going to end these two. Okay, so I'm going to be using this for loop right here, this nested for loop, each time I need to do something through the entire table, the board table. So I'm going to be using that same style every time now. The size will be used later in the draw. Now I just realized I don't have the setup for I need to seed this random number generator. So I'm going to put this in the load so it seeds the random number generator. I'm not going to put a comment because the name of the method is so obvious, it's self-documenting. Okay, so that should seed our random number generator. Now we're using a random number generator to fill in the table with random numbers, 0 or 1. So I'm going to call this method from here, reset. So whenever it loads, it creates the table. It actually sets the table up for random. We also need to draw this table. So to draw this table, the first thing I want to do is clear the screen. So we already know how to draw a rectangle because we've seen it in the very first demo that I did. Right here. Right here is a rectangle fill. So I'm going to use this to clear the screen. So what I'm going to do is I'm going to set the background color to zeros, and I'm going to use this rectangle fill. That's how I'm going to blank my screen over and over again. In the prior game, I was always drawing a background image so that I didn't need to clear anything because that image was always being put on the render. This time, I'm just going to blank it out with a rectangle. That's going to be black. So let's create a draw function. Like I said, the first thing I want to do is set a color to black and then draw a rectangle. This is in graphics. Set color. There's probably another way to do this, but for black, all the colors in Lua go from 0 to 1, and they're a floating point number. So 0, 0, 0 is black, 1, 1, 1 is white. If you wanted, say, red, since it's RGB, you would have 1, 0, 0. That would be red. If you wanted blue, it would be 0, 0, 1. If you wanted green, it would be 0, 1, 0. And then you can put any kind of, 0.2, 0.5, however you want to do it. But we're dealing with just black here, so that is all the colors turned off, which is just zeros. Okay. And this one is going to be rectangle. And the first thing I want to do is have it a filled rectangle, so I'm going to add fill. And I want it to start in the top left of the screen, so it's going to be at 0. That's X. 0 is Y. And now the bottom right of this rectangle is going to be the width of the screen and the height of the screen. Right? So it's starting at 0 and going all the way to the width for the X, and it's starting at 0 on the top and going all the way to height, which is the bottom of whatever the game window will be. Okay? So I'm going to use my constants above that are width and height. So that will blank out the screen each time. Now, to draw these cells, I actually want them to be medium gray. So I'm going to change the color again. I'm just going to grab this method up here and just change it to gray. And the way I'm going to do that is just change all these to 0.5. So anything I draw right now will be a medium gray. So I'm going to do the exact same thing I did up here with iterating through the board. I'm just going to copy the entire thing here. The only thing that needs to change is this right here. Okay, so we are going through this whole thing, but on this one, I actually want the value. So remember, I'm grabbing the row, the number of the row, which is a table. I mean, it's a number, but that row is a table. That table holds the column, so I'm calling that table columns. Now I'm looking at the columns table, and I grab the actual iterator number of the column, but what is actually contained in that? What's the item in it? Well, it's not a table this time, it's an actual value, which could be a 0 or 1. So I'm going to call that value. Because I do need to test it. If it's a 1, I'm going to draw it. If it's a 0, I'm not going to draw it. We'll say if value, we're doing the double equals, so we're checking to see if it is 1. That's a, we're not setting it, we're checking equality. The issue with this is since Lua is 1 based, they're all going to be offset by 1. It's not going to be correct. So I need to subtract 1 from it. I need to create the size of the cell for it to draw correctly. Otherwise, it would all be drawing one square over and one square down, because like if I want to talk about X and Y drawing, the first item right here, let's say I have this. So if I'm drawing this star right here, the very top of this is 0, 0. And if the star is 10 pixels by 10 pixels, the bottom left corner will be 10, 10. So 0, 0 to 10, 10. So what I can do is I can take the number of the table, assuming I was starting at 0, that table, and I draw that, and then the width of that, the other side of that table will be multiplied by the size of the cell. So at the 0 position, if I take 0, multiply it by 10, the size of the cell, I still get 0. Over here, the next table over, the next cell over, will be, this cell will be cell 1. So if I take 1, multiply it by 10, I'm at the 10th pixel, which is correct. That's correct. And for the third one, if I take 2 and multiply it by 10, it starts at 20, and that's all correct. But Lua is 1 base, so if I were to take 1 and multiply it by 10, I get this one, and I never draw this one. So I need to actually subtract 1. There's going to be a bit of this going on that you don't have to do in other languages, just because Lua is 1 based, which is the worst thing about the whole language, because it causes these issues. So I'm going to create 2 local variables for X and Y just to find out where X and Y needs to start being drawn at. And I'm going to use the columns and rows, but I need to subtract 1 from the columns and rows because both columns and rows start at 1 and they need to start at 0. So I'm going to say local X. The X is going to be where I want to start drawing from. So it's going to be column, whatever the column is for that, as we're going through this loop, minus 1. And then I'm going to multiply it by the cell size. Okay? So as again, if I'm at the first one, this will be a 0. 0 times cell size, say that's 10. 0 times 10 is 0, and I'm starting at the correct spot. For the next cell over, that will now be cell 1. It would be 2 for columns, but it'll end up being 1. 1 times cell will be 10, and that will be where the next cell should start drawing. So again, this is where they're starting to draw. So it's same for rows. So this is going to give me where I'm starting to draw it at. And then cell size will be the width and the height. So I'm just going to use the rectangle that we've already used to blank the screen. But this is going to be for each cell that I'm drawing. So I'm going to say filled again. And it's going to start at X. It's going to start at Y for X and Y. And then it's going to be size and size. And the reason why it's size and not cell is because if I put size in there, or if I put cell in there, we would have no borders. But remember, size is just cell minus 1. So what's going to happen is if my cell, it's not 10. I know it's not 10 up here, but just imagine it's 10 for easy numbers. If my cell size is 10, so this thing says, hey, I'm at 0, 0. I'm drawing to 9, 9. The next cell over starts drawing at 10. There's 1 pixel that's not drawn. And it doesn't draw to 20, it draws to 19. Right? And that's on the X and the Y. So that's why I'm using size. And we'll see this. We'll see this in the demo in a second here. So that should be everything that I need for the if statement. I think that's all I need for drawing. So we should be able to see something happening now. Okay, I believe I don't have any issues. So what we need to do now is really quickly set up our main. And this one's going to be pretty straightforward because we're just linking into the game is all we're doing. We're just telling the love stuff to link into the game table. It's a singleton object. So I'm going to require the game so that we have access to it. So that gives us access to game. So we got the love.load, and I'm just going to pass it off to game.load, or game::load. And we also want to draw this, and we have a method to draw it in game too. We've created, so I'm going to do the same thing. Draw. Now, I also want to be able to exit this game without telling it to exit just on the escape key. We've already seen this in the last two projects, so I'm just going to type it in. It's a function that we're defining for love. So every function we're defining for love, I'm putting it in the main.lua file. Every function we're defining for game, I'm putting in a game module. So this one is called love. What we're doing is it's expecting to see these functions defined. So if it sees them defined, it calls them. So this is love.keypressed, and we're going to have key. It doesn't have to be key. You can put K there if you want. We're checking equality on the key to see if it's the escape key. And this is just going to quit the game. And actually, we could put another one in there. Since we've made reset, that randomizes the board. Since we've made that into a module already, we can just go ahead and put it in here. So I'm going to say else if key equals, and I'm just going to put the R key. And I can just say game reset. And let's check another one in here. Let's clear it too. Why not? I know we haven't made the clear method yet, but it's going to be very simple. So that is everything that's going to be in here. Let's just go back real quick to game, and we'll just take this reset. I'm just going to copy this, put it down here, and change the name to clear, and just change this to 0. Because it's just iterating through the table, but we can just set everything to 0, and that should give us a way to reset it and to clear it. Let's see, after all this code, I know I didn't open a window this whole time. This is just kind of bootstrapping the whole thing, but let's see if I made any huge mistakes. And I did. Cool. For limit must be a number, so we're looking at game 18. Let's see what's going on there. I'm in game, down to 18. I put column here and columns here. That's my issue, I believe. Okay. Let's see if there's any other issues. Okay. So I'm going to hit the R key. Looks like random's working. I'm going to hit C. C is working. R again, C, and escape. Okay. So that was a whole lot, just trying to bootstrap this whole thing, get it up and running. And let's check out if we can change the size. So what if I didn't want to have this border? So if I just remove this here, and then we open it up again, see how there's no border being drawn between them? We can make them bigger too. So right now they're they're 9. Let's make them like 30. Okay, see they're much bigger now, and see how it doesn't come over here. There's a kind of a border here. That's because there couldn't be a full cell being drawn here. So because there can't, the last full one is drawn here, and it looks like it made it down on the bottom. It could happen here on the right side and on the bottom side as well. But it looks like the bottom mathematically it worked out, but it didn't work out on the width. And so we've changed those, and that table is not being drawn past the size of the game window. So earlier on when I was testing this out, I was actually having issues with it being drawn past it. It's not being drawn past it. So let's go into conf and let's change it to a bigger number. Say 1400 by 900. Because of the way we're calculating things, so we still have it not matching down here, but it is here. We could change that number so that it does it in both. And this one. So looks like this has been changed. Let's just put it some weird number like 42 or something. No, it keeps not giving me a border down here. I want it to give me a border down there. There we go. So you can see that it only draws the one if it can fit a whole one in there. And that's not just drawing it on the screen that way, it's made the table that size. So the table never exceeds the window size that you set for it. And it's very easy. You can just choose the window size you wish, and you can choose the padding or the, like if we want to go in here and put this to 5. Now that we got 5 pixels in between each square because everything's bigger now, so you can kind of have fun, and it's very easy to change the cell size, the padding size, the screen size. Everything else dynamically gets calculated for you in the game, so it's pretty great. So that's going to be the end of this one. I hope you enjoyed that, or it was educational, and try to have a good day. Bye.